In the vast blackness of space, where stars shimmer like ancient embers scattered across eternity, there lies a question that has haunted humankind since the dawn of thought. How big is the universe? Nova's voice begins softly, echoing against a silent cosmic backdrop. Our planet, Earth, floats alone, a fragile sphere of blue and white, suspended in a sea of infinite darkness. From here, the universe feels endless, but our minds are limited. Our sense of scale, built for measuring mountains and oceans, collapses when faced with the immensity of the cosmos. To begin this journey, we start small from the world we know. Earth, with its swirling clouds and endless oceans, measures a mere 12,742 kilometers across. It seems vast when you stand upon its surface, but in the grand picture of the universe, it is nothing more than a speck of dust. The Moon, our nearest neighbor, lies just 384,000 kilometers away, a distance so great it once took humanity's greatest machines days to cross. Yet, in the cosmic scheme, that gap is so small it's almost touching. Beyond the Moon lies the Sun, the beating heart of our solar system. It sits 150 million kilometers away, and its light, traveling at the fastest speed known, takes 8 minutes to reach us. That light, ancient and pure, has crossed the void just to touch our faces. Nova explains that this simple ray of light, something we take for granted, is the key to understanding distance itself. For when numbers become too large, astronomers turn to light years. The distance light travels in 1 year, about 9.46 trillion kilometers. It's a number so large, it defies visualization, a measure meant for the universe, not the human mind. To imagine 1 light year, we must leave behind the comfort of what we know. If the Sun were reduced to the size of a grain of sand, the nearest star, Proxima Centauri, would still lie over 4 kilometers away. Every other star in the night sky would be scattered across continents. This is the scale of space distances so vast, they strip away all sense of familiarity. As Nova's narration deepens, we travel through our solar system. Planets drift silently, each separated by oceans of emptiness. Mercury burns close to the Sun, its surface scorched by heat. Venus, cloaked in toxic clouds, shines like a deceiving jewel. Earth, vibrant and alive, is followed by Mars, cold and red, a world frozen in time. Beyond them, the giants loom: Jupiter, with its swirling storms larger than Earth itself, and Saturn, a world adorned with delicate rings of ice and rock. Then come Uranus and Neptune, far and lonely, drifting in the dim glow of sunlight, stretched thin by distance. The vast gulf between Neptune and the next significant object, Pluto, reminds us that even within our solar system, emptiness dominates. Light from the Sun, so fast it circles Earth 7 times in 1 second, takes more than 5 hours to reach Pluto. To travel there by rocket would take years. Yet, beyond Pluto, beyond the Kuiper Belt and the frozen remnants of our system, lies the real mystery, the interstellar void. Nova explains how space is not empty in the way we imagine. It is filled with invisible particles, radiation, and the faint whispers of cosmic background energy, remnants of the universe's birth. The vacuum stretches endlessly, silent and cold, with temperatures near absolute zero. Time itself behaves differently here, slowed by gravity and warped by motion. It is a realm where human understanding begins to dissolve. But to comprehend how big the universe truly is, we must step outside of our small solar system, the Sun. Immense and life-giving, is merely one of hundreds of billions of stars in the Milky Way galaxy. If our solar system were a grain of dust, the Milky Way would be a sprawling metropolis of stars, 100,000 light-years wide. Light takes 100 millennia to travel from one end to the other. Inside it, stars cluster together in spirals and arms bound by the invisible force of gravity. Nova's voice softens as she describes how our ancestors once believed the universe ended at the edge of the Milky Way. They thought it was everything, all creation contained within its glittering circle. But telescopes changed everything. With each lens and mirror, we pushed farther into the unknown, discovering that our galaxy was just one among countless others. What we once thought was the universe turned out to be a single chapter in an infinite book. We pull back, farther still, and the Milky Way becomes a shining whirlpool of light surrounded by darkness. Then, as the camera moves outward, other galaxies appear. Andromeda, our nearest neighbor, lies 2.5 million light-years away. The light we see from it tonight began its journey when early humans were just beginning to walk upright on African plains. To gaze at the stars, Nova explains, is to look through time itself. Every beam of light carries a story, an image from a past that can never be relived. In the night sky, each point of light is a sun, many with their own planets. Some may host life, others may already be dead. Stars are born, live, and die in cycles that span billions of years. When massive stars explode as supernovae, they scatter elements into space, elements that form new stars, planets, and even life itself. In a way, we are made from stardust, bound to the universe by matter and memory. Nova's narration becomes reflective as we confront the limits of perception. When we speak of distance in space, we are also speaking of time. The farther away something is, the older the image we see. When we look at distant galaxies, we see them not as they are, but as they were billions of years ago. The deeper we look, the younger the universe appears, until we are staring at its infancy, the faint afterglow of the Big Bang itself. This realization reshapes everything. The universe is not static, it is expanding, stretching out in every direction. Even as we observe it, space grows larger and galaxies drift farther away. Some are moving so quickly that their light will never reach us. They are already beyond our cosmic horizon. The visible universe, vast as it seems, may be only a small portion of an endless reality. Nova pauses as the narration turns philosophical. What lies beyond the edge of the observable universe? Does it simply stop, or does it continue forever? The answer remains one of the greatest mysteries in science. Some theories suggest the universe might curve back upon itself like the surface of a sphere, meaning if you traveled far enough in one direction, you could eventually return to where you started. Others propose that it stretches infinitely, with no end, no boundaries, only endless repetition. She speaks about how the human mind struggles to imagine infinity. Our brains are built for survival, not cosmic understanding. Yet, despite our limitations, we continue to ask questions, to build instruments that look deeper into the void. Telescopes like Hubble and James Webb act as our eyes into eternity, capturing light that has traveled across billions of years. Through them, we glimpse the earliest galaxies, tiny clusters of stars flickering in the newborn universe. As Nova describes this, we zoom in on a single image taken by Hubble, a deep field shot showing thousands of galaxies packed into a tiny patch of sky. If you held your thumb out at arm's length, the area it covers would contain millions of galaxies. Each galaxy holds billions of stars, and each of those stars could host worlds of its own. Suddenly, the question, how big is the universe, becomes almost meaningless. The scale has surpassed comprehension, but there's beauty in that incomprehension. Nova reminds us that the universe's immensity does not make us insignificant. Rather, it connects us to something larger. We are not separate from the cosmos. We are its expression. The atoms in our bodies were forged in ancient stars. Our planet was born from the debris of long-dead suns. In that sense, the universe is not out there, it is within us. As we drift deeper into the cosmic panorama, Nova's tone becomes serene. She explains that measuring the universe is not only about numbers and distances, it's about perspective. When we ask how big the universe is, we are really asking about ourselves, about the scale of our curiosity, our courage, and our capacity to wonder. The screen fades to the image of Earth again, small and glowing in the blackness. All of humanity's history, every empire, every story, every heartbeat, fits within that tiny sphere. From the edge of space, it seems fragile, almost invisible. Yet from this same place, our species dared to dream of the stars, to build telescopes, to reach the moon, and to imagine the infinite. Nova concludes softly, "The universe is not only bigger than we imagine, it is bigger than we can imagine." And as her words fade, the camera keeps zooming outward, past planets, past stars, past galaxies, until even the largest structures dissolve into darkness. In that infinite black, silence reigns. But it is not emptiness, it is potential, mystery, and endless possibility. We are a part of that mystery. And though we may never fully grasp how big the universe truly is, our desire to understand it, to look up and ask why, is what makes us eternal. The first step in measuring the universe begins with wonder. And that, Nova says, is the greatest distance we will ever cross the journey between knowing and awe. The journey through the universe continues, and now Nova turns her gaze toward our own corner of the cosmos, the solar system. She calls it our cosmic neighborhood, a delicate arrangement of planets, moons, asteroids, and frozen relics orbiting a single golden star. From the outside, it appears peaceful, balanced, and quiet. But within this vast expanse, chaos, motion, and emptiness rule everything. The story begins with the sun, the center of it all. It is more than just a light in the sky. It is a nuclear furnace, a churning ball of plasma, 1.4 million kilometers across, containing 99.8% of all the mass in the solar system. Its energy powers everything: the winds on Earth, the tides in our oceans, the very spark of life itself. Nova describes how, deep inside its core, hydrogen atoms fuse into helium, releasing an unimaginable amount of energy. This process has continued for over 4.5 billion years and will continue for billions more. As Nova speaks, we zoom out from the Sun and the first planet comes into view: Mercury. It orbits closer than any other, scorched by intense radiation. Its surface, a landscape of craters and silence. One day on Mercury lasts longer than its year. There is no atmosphere to scatter light, so the sky remains eternally black. The planet's temperature swings wildly, from 430 degrees Celsius in the daytime to minus 180 at night. Yet, in its desolation, Mercury reflects the raw beauty of proximity, a world held too tightly by the sun's grip. Further out drifts Venus, shrouded in thick, toxic clouds of sulfuric acid. Beneath that veil lies a world once thought to be Earth's twin, but its similarity ends at size. Venus is a furnace, with temperatures exceeding 470 degrees Celsius and atmospheric pressure strong enough to crush metal. Lightning flashes through its poisonous clouds, and winds scream at hundreds of kilometers per hour. Nova calls Venus a warning, a glimpse of what happens when a planet turns against itself. Then we reach Earth, the oasis of life. Seen from space, it glows blue and white, wrapped in a thin film of atmosphere that shields it from the harshness of space. Nova's voice softens as she describes how delicate this balance truly is. Oceans, clouds, continents, and the fragile ecosystems that make our planet unique. Earth is just one world among billions, yet it is the only one we know that breathes. Our existence here is both miraculous and fleeting. Beyond Earth, the red planet appears Mars, cold, barren, and silent. Its dusty plains and massive volcanoes tell a story of a world that once had water, rivers, and perhaps life. Nova explains that Mars is not entirely dead. It still trembles with quakes, and its ice caps whisper of a warmer past. It represents the boundary between what is known and what might still be discovered, a place where humans dream of stepping next. The journey continues into the outer solar system, where the giants reign. Jupiter appears first, a world of unimaginable scale. More than 1,000 Earths could fit inside it. Storms swirl across its surface, including the Great Red Spot, a hurricane larger than our planet that has raged for centuries. Nova describes Jupiter as both protector and destroyer. Its immense gravity captures asteroids and comets, shielding Earth from impacts, but also flings others into the inner solar system. Around it, dozens of moons orbit, each a world of its own. Europa hides an ocean beneath its icy crust, and Io burns with volcanic fury. Then comes Saturn, the jewel of the solar system. Surrounded by rings of ice and dust, it is both majestic and mysterious. The rings, delicate and shimmering, stretch hundreds of thousands of kilometers wide, but are only meters thick. They may be remnants of a shattered moon or leftover debris from the birth of the solar system. Nova speaks with reverence as the camera drifts through the rings, each particle glinting in sunlight like frozen diamonds. Farther still, the pale blue giants appear. Uranus rolls through space on its side, its rotation tilted by a long-ago collision. Its atmosphere of methane gives it a ghostly hue. Neptune, darker and more distant, howls with supersonic winds, the fastest in the solar system. Beyond Neptune, light from the sun grows weak, dimming into the infinite night. The solar system here begins to blur into the unknown. Nova reminds us that even though the planets feel near when we see them in books or diagrams, the true distances between them are vast beyond imagination. If the sun were the size of a basketball, Earth would be a tiny bead 8 meters away. Neptune would be nearly 250 meters farther. And beyond that, there would still be emptiness, a darkness that stretches for billions of kilometers before the next thing appears. Past Neptune lies the Kuiper Belt, a region filled with icy bodies and dwarf planets like Pluto, Makemake, and Haumea. They orbit the sun in slow, distant paths, frozen in time. These are the leftovers of creation, ancient fragments that never formed into full planets. Nova explains that studying them helps scientists understand the early solar system. The chaos that once reigned before gravity sculpted order from dust. Beyond the Kuiper Belt is the heliopause, the boundary where the solar wind, a stream of charged particles from the sun, finally meets the cold breath of interstellar space. It is here that the domain of our star ends. Voyager 1 and Voyager 2, tiny human-made probes launched decades ago, have now crossed this invisible frontier. They are the farthest objects humanity has ever sent, carrying messages written on golden records, sounds and greetings from Earth, meant for whoever might find them one day. Nova reflects on what these small machines represent: not just technology, but hope. They are our whispers into eternity, drifting through the darkness, carrying proof that we once looked beyond ourselves. And yet, even they have only just begun their journey to reach the nearest star, Proxima Centauri. Voyager would need more than 75,000 years. The solar system, which feels so immense to us, is in truth only a drop in a cosmic ocean. When compared to the vastness of the Milky Way, it becomes invisible, a tiny point orbiting a single star among hundreds of billions. And still, this small neighborhood is all we have ever known. Nova's tone becomes contemplative as the camera zooms out from the edge of the solar system. The sun shrinks to a star among countless others. She reminds us that this vast structure of planets, moons, and ice worlds is our birthplace, the only part of the cosmos where we have walked, flown, and dreamed. Every grain of sand on Earth, every thought and song, was born under this same star. As the final image fades, the solar system becomes just one of millions of similar systems scattered across the galaxy. Nova concludes softly. We call it our solar system, but in the language of the universe, it is only one story among billions. To know its size is to realize our smallness, yet also our significance. For from this tiny system, we dared to imagine the infinite. The camera continues to pull away, drifting past the last traces of the heliosphere, past the cold silence of the void. The sun, once so powerful, now fades into a faint point of light among many. And as it disappears, Nova's final words linger. The journey has only begun. The true scale of the universe lies far beyond our little neighborhood, waiting to be seen, waiting to be understood. As Nova's voice returns, the darkness deepens. The solar system fades into the distant background, and our journey stretches outward into the interstellar void, a vast sea separating us from the next stars. Here, in this emptiness, space is no longer defined by planets or light, but by silence, distance, and time. This is the realm between stars, where even light itself takes years to travel, and where the scale of the universe begins to reveal its true magnitude. Nova explains that when we speak of the nearest stars, the word near is deceptive. The closest star system to our own is Proxima Centauri, part of the Alpha Centauri system, located about 4.24 light-years away. To grasp this, imagine light, the fastest thing in the universe, traveling at 300,000 kilometers every second. Even at that impossible speed, it takes over 4 years to reach us. Nothing humanity has built comes close to that. Voyager 1, our most distant spacecraft, would need over 70 millennia to arrive. As Nova speaks, we begin to see these neighboring stars, Alpha Centauri A and B, twin suns locked in an eternal dance, with Proxima Centauri circling from afar. They shine brightly in the blackness, each surrounded by their own invisible worlds. Around Proxima orbits an exoplanet known as Proxima b, a rocky world within its star's habitable zone. Though bathed in deadly radiation, it still sparks the imagination, a reminder that even in the nearest systems, there could be other homes for life. The camera drifts through space, passing between glowing stars scattered across the darkness. Nova describes how most of these stars are not solitary like our Sun. Many exist in pairs, trios, or even greater clusters. They orbit each other in delicate gravitational harmony, their light weaving together to create the constellations we see from Earth. But those patterns, she reminds us, are illusions. The stars we connect with lines in the sky are not close together at all. Some lie hundreds of light years apart, their connection existing only from our point of view. As we continue moving outward, Nova explains how light serves as both a measure of distance and a messenger of time. When we look at Sirius, the brightest star in the night sky, we see it as it was 8 years ago. When we look at Vega, we see light that began its journey 25 years ago. The farther we gaze, the further back in time we peer. Space is not a place. It is a timeline, written in light. The stars themselves are not eternal. Nova describes their life cycles born from clouds of dust and gas that collapse under gravity, igniting into nuclear furnaces. They shine for millions or billions of years, depending on their size. Small stars burn slowly and steadily, while massive ones live fast and die in cataclysmic explosions. In death, they scatter their elements into space. The oxygen we breathe, the carbon in our bodies, the iron in our blood. In a poetic truth, we are the children of ancient stars. As Nova narrates, the scene shows a stellar nursery, a region like the Orion Nebula. Within swirling clouds of gas, new stars flicker to life. Their light pierces through the haze, illuminating pillars of dust that stretch for light years. These are the cradles of creation, where planets begin to form from leftover debris. Each tiny particle collides, sticks, and grows, eventually becoming worlds orbiting new suns. Beyond these nurseries, Nova describes the death of stars, red giants expanding to consume their planets, and white dwarfs cooling into silence. Massive stars collapse into neutron stars or black holes, where gravity becomes so strong that even light cannot escape. Around them, space bends and time slows to near stillness. Though invisible, black holes reveal their presence through their power, devouring gas, stars, and sometimes entire systems. The narration turns reflective. Nova explains that between these stellar systems lies emptiness so vast that a beam of light can travel for years without encountering a single atom. The density of matter in interstellar space is incredibly low, just a few atoms per cubic centimeter. Yet this near void is filled with energy, radiation, and magnetic fields. It is not dead, but alive with invisible movement, a cosmic ocean with tides of gravity and waves of light. The journey continues toward Betelgeuse, the red supergiant in the constellation Orion. Nova explains that this star, nearing the end of its life, is enormous. If placed at the center of our solar system, it would engulf Mercury, Venus, Earth, and even Mars. One day, it will explode as a supernova, briefly outshining entire galaxies before fading into darkness. When that happens, the light from its death will take 640 years to reach us, meaning it could already have happened, and we simply haven't seen it yet. We move next to Vega, bright and blue, a younger and hotter star. Nova explains how Vega spins so quickly that its equator bulges outward, distorting its shape. It is one of the most studied stars, a symbol of human curiosity about the cosmos. Yet even it is just one of billions. As we pass these familiar stars, Nova highlights an astonishing truth. The human eye can see only about 6,000 stars in the entire sky, even under perfect conditions. But in our galaxy alone, there are more than 200 billion. Most are too faint, too distant, or hidden by dust. The stars that fill our night sky are merely the brightest nearby lights, the tip of an unimaginable iceberg. The scale becomes more mind-bending when Nova describes how interstellar distances are measured. Scientists use parallax, observing how a star appears to shift position as Earth moves around the Sun. But beyond a few thousand light-years, even this method fails. The distances become too great, the movement too small to detect. Instead, astronomers rely on light itself, measuring color, brightness, and redshift to determine how far away a star truly is. The universe speaks in the language of light, and we are just beginning to learn how to listen. As Nova continues, the visuals shift to star clusters, groups of stars born together from the same cloud of gas. We see the Pleiades, the Seven Sisters, a bright blue cluster glowing against the night. These stars are young, only 100 million years old, and still surrounded by faint remnants of the dust that birthed them. Farther away lies Omega Centauri, a massive cluster containing millions of ancient stars. It is a glimpse into the early universe, a relic from a time when galaxies were still forming. Beyond these, we approach the edge of our local region of stars, a sphere about 1,000 light-years across, known as the local bubble. Nova explains how this vast cavity was carved out long ago by supernova explosions. Sweeping away gas and dust, our Sun happens to drift inside it in a relatively calm pocket of space. As we leave the local bubble, Nova's tone grows more awestruck. The number of stars multiplies, their light blending into a faint, glowing band, the Milky Way itself. From this perspective, we begin to see that our Sun, our planets, and our neighboring stars are all part of something vastly larger, a single spiral arm among many. But before moving to the galactic scale, Nova pauses to reflect. When we look at the stars, she says, we are not just seeing distant suns. We are looking across time, across the history of existence itself. Every point of light in the night sky is a window into another era, another reality. And together, they form a map, not of space, but of our place in the universe. As her words echo, the camera drifts outward, showing the entire cluster of nearby stars, a glowing swarm suspended in the dark. Their light forms constellations, then dissolves into a blur. As we zoom farther and farther away, the individual stars merge into a faint, milky glow, revealing the edge of our galactic home. The screen fades to black as Nova whispers. We've traveled beyond the reach of our Sun, past the nearest stars, and still we have not even begun to touch the true scale of creation. The universe stretches on, vast, silent, and unending. The next step in our journey awaits, the heart of the Milky Way galaxy. The screen fades from black into a vast panorama of swirling light, the Milky Way galaxy. Nova's voice returns, calm and reverent, as the view slowly rotates across a spiral arm shimmering with billions of stars. This is our home on a cosmic scale. She says, a colossal city of suns drifting through space. Our Sun, so vital and powerful to us, is just one star among hundreds of billions, quietly orbiting the galaxy's center like a grain of sand in a storm of light. The Milky Way stretches across 100,000 light-years in diameter. From edge to edge, light traveling at the fastest speed in the universe would take 100 millennia to cross it. If our solar system were the size of a coin, the galaxy would be as large as North America. Within this boundless realm lie planets, nebulae, black holes, and untold mysteries that remain hidden in the darkness. Nova explains that our Sun resides in one of the spiral arms, the Orion Arm, a small offshoot between two major arms called Sagittarius and Perseus. It orbits the galactic center at a speed of 828,000 kilometers per hour, taking about 230 million years to complete a single rotation. In the time since the dinosaurs walked the Earth, our planet has only completed one full orbit around the Milky Way. Every civilization, every life that has ever existed, has taken place during a single galactic moment. As Nova narrates, the visuals sweep through the galaxy's glowing arms. Immense clouds of dust and gas stretch for thousands of light-years, illuminated by newborn stars. These are stellar nurseries, the factories of the cosmos, where gravity pulls atoms together until nuclear fire ignites. We pass through the Eagle Nebula, where towering pillars of gas, known as the Pillars of Creation, rise like ancient cathedrals sculpted from light. Inside them, new stars are being born even now, hidden from view by dense curtains of dust. Farther along the spiral arms, we see the aftermath of stellar death supernova remnants, expanding shockwaves glowing in brilliant colors. Nova describes how the death of one star sows the seeds of countless new worlds. The elements formed in its core, carbon, oxygen, silicon, iron, scatter through space, eventually coalescing into new stars and planets. In this endless cycle, the galaxy renews itself, generation after generation. As we drift closer to the galactic center, the stars grow denser, packed tightly together like lights in a vast cosmic metropolis. Here, time and space themselves begin to distort under the immense pull of gravity. At the very heart lies a supermassive black hole, Sagittarius A*, containing 4 million times the mass of our Sun. Nova explains that this monster is invisible, its presence revealed only by the way it bends light and devours nearby matter. As gas and dust spiral into its grasp, they heat to millions of degrees, emitting powerful bursts of energy. Yet, despite its destructive force, this black hole plays a vital role. Its gravity shapes the galaxy, influencing the orbits of stars and maintaining the delicate balance of the Milky Way's structure. Black holes, Nova says, are not merely ends, they are architects of creation. From the galactic core, the camera pulls outward, revealing the full majesty of the Milky Way. Its spiral arms rotate slowly, glowing with clusters of stars. Countless worlds orbit within it, some warm and blue, some cold and dark, others shrouded in alien atmospheres. Nova reflects that if even a small fraction of these worlds harbor life, then the galaxy could be teeming with civilizations, perhaps billions of them, scattered across distances so immense they may never meet. She pauses, her tone softening. Our galaxy is a paradox, she says, so full of stars and yet so empty. The average distance between stars is so vast that a journey from one to another, even at the speed of light, would take years or centuries. For now, we remain prisoners of our own system, able only to look out and dream. We zoom through the galactic plane, passing globular clusters, ancient spherical collections of stars orbiting the Milky Way like cosmic satellites. Some of these clusters are nearly as old as the universe itself, containing stars that have burned since the dawn of time. They are the galaxy's memory, preserving the history of its birth and evolution. Nova explains how scientists believe the Milky Way formed more than 13 billion years ago from the collision and merging of smaller galaxies. Over time, gravity sculpted it into its current shape, a grand spiral, alive and changing. Even now, the galaxy continues to evolve. Streams of stars stretch out like rivers, evidence of past galactic mergers. Our galaxy, she says, is not static. It is a living, breathing entity, shaped by both creation and destruction. As we travel farther outward, the Milky Way begins to appear as a single glowing disk against the darkness. Nova describes how difficult it was for humanity to even realize we lived inside a galaxy. For thousands of years, people believed the Milky Way was a band of light painted across the sky. Only in the early 20th century did we discover that it was made of billions of distant suns and that there were countless other galaxies beyond. The moment we learned that, Nova whispers, was the moment the universe grew immeasurably larger. The camera continues pulling away, and the galaxy begins to shrink, its arms fading into the background of stars. From this distance, the Milky Way becomes one of many, a single island of light in an ocean of galaxies. Nova reflects on what this means for our understanding of existence. If every star is a sun, she says, and every galaxy holds billions of suns, then how many worlds must there be? How many skies? How many oceans? How many beings looking back at their own stars and wondering if they are alone? The visuals slow, revealing the galaxy from above, a glowing whirlpool of white, blue and gold spinning gently in the void. Nova's voice turns thoughtful, almost melancholic. We are the universe becoming aware of itself. We are stardust that learned to see. Our galaxy is not just our home, it is our origin and our destiny. The camera begins its long retreat from the Milky Way, showing it surrounded by a few smaller companion galaxies, the Magellanic Clouds drifting nearby like loyal companions. Nova explains that these are dwarf galaxies, bound by gravity, slowly being pulled apart by the Milky Way's immense force. In billions of years, they too will merge, their stars becoming part of ours. As the view widens, the Milky Way's soft glow becomes just one light among many. Galaxies now fill the screen, spirals, ellipticals, irregular shapes, each containing its own suns, worlds, and mysteries. Nova's voice fades to a whisper. We have crossed the boundaries of our home, leaving behind every star we know. What lies beyond is greater still, a realm of countless galaxies bound together by gravity, shaping the vast cosmic web of the universe. The final image shows the Milky Way from a distance, drifting quietly in space, a brilliant spiral among billions. Nova concludes, in the grand architecture of the cosmos, our galaxy is neither large nor small. But for us, it is everything, the cradle of life, the memory of time, and the first step toward understanding how truly big the universe is. As the last light of the Milky Way fades into the dark, the narration lingers in silence, carrying the weight of infinite distance and the promise of the next great leap beyond our galactic home. The darkness returns vast, silent, infinite. But, as Nova's voice breaks the quiet once more, new light begins to emerge, scattered across the void like jewels in a cosmic sea. Beyond the Milky Way, she says softly, lies our galactic family, a collection of galaxies bound together by gravity, moving through the universe in an endless cosmic dance. This is the local group, our home cluster among the stars. Though small compared to the universe, it contains hundreds of galaxies, each one a realm of its own. The Milky Way is not alone. Its nearest companion, the Andromeda galaxy, looms 2.5 million light-years away. Even at light speed, the journey there would take longer than the entire history of humanity. Yet, on the grand scale of the cosmos, Andromeda is close our sister galaxy, similar in size and structure, a mirror of our own home, swirling silently through the darkness. Nova describes Andromeda as a majestic spiral, larger than the Milky Way, containing perhaps 1 trillion stars. Telescopes reveal its glowing core, its arms stretching outward like cosmic wings. Between its stars may orbit untold worlds, some perhaps rich with oceans, others barren and cold. The light from Andromeda that reaches Earth tonight began its journey long before humans existed, traveling across the blackness of intergalactic space for millions of years before arriving as a faint shimmer in our sky. When we look at Andromeda, we see it as it once was, not as it is now. As Nova narrates, we drift closer, watching the two galaxies, the Milky Way and Andromeda, slowly drawn together by their mutual gravity. They move toward one another at a speed of nearly 400,000 kilometers per hour. In about 4 billion years, they will collide, merging into a single massive galaxy. It will not be a violent clash of matter, for the distances between stars are too vast. Instead, they will pass through one another, their shapes twisting and reforming in a slow ballet that lasts billions of years. Nova's voice deepens. The future of our galaxy is written in this motion. It is the destiny of light to merge, to transform, and to continue. Around the Milky Way and Andromeda orbit, smaller galaxies, faint, irregular, and ancient. These include the large and small Magellanic Clouds, visible from the southern hemisphere as glowing patches of light. They are dwarf galaxies, bound to the Milky Way by gravity, slowly being torn apart by tidal forces. Nova explains how their stars are being stripped away, forming trails of gas and light that stretch across millions of kilometers, blending into our galaxy's halo. Beyond them are dozens more tiny, dim galaxies, like Sculptor, Leo I, and Draco, remnants of ancient collisions, survivors from the dawn of the cosmos. Some contain only a few million stars, others are almost invisible, hidden in darkness. Yet each one tells a story of creation, destruction, and rebirth. Nova explains that the local group, though relatively small, holds together through the invisible threads of gravity, forming a family of galaxies drifting through space. As we zoom out, the scale becomes clear. The local group spans roughly 10 million light-years across a bubble of gravitational influence floating in a much larger structure known as the local sheet. Within this expanse, galaxies are not isolated. They are connected through delicate interactions, pulling, twisting, and shaping each other's destinies. Nova describes how these cosmic interactions are not chaotic, but part of a larger order, the grand architecture of the universe. Galaxies form groups, groups form clusters, and clusters link together into superclusters, immense webs of light stretching across the cosmos. Our local group is part of the Virgo supercluster, itself a member of an even larger structure called Laniakea, a vast network of tens of thousands of galaxies bound together in a gravitational flow. The visuals shift to show Laniakea an incomprehensible web of glowing filaments and dark voids spanning hundreds of millions of light-years. The Milky Way, the Andromeda galaxy, the local group all appear as a single glowing point within its structure. Nova's voice carries a tone of awe. Our entire galactic family, everything we know, every star we've ever seen, all of it is just one dot in this immense flowing web. And even that, vast as it seems, is only a small piece of the observable universe. But Nova reminds us that even here, amid the grand scale, there is motion and life. Galaxies orbit one another, collide and merge, constantly evolving. Every collision gives birth to new stars, reigniting creation in places where dust once lay dormant. She describes how, when the Milky Way and Andromeda finally combine, their supermassive black holes will spiral toward each other, merging into one, an event so powerful it will send ripples through the very fabric of space-time. These gravitational waves, like echoes of the universe's heartbeat, will spread across billions of light-years. The narration slows, and Nova's voice softens into reflection. The local group is our home in the universe, but it is also a reminder of the constant motion of all things. Even galaxies are travelers wandering through the cosmic sea, colliding, merging, and changing. Nothing in the universe is still. Everything flows, everything moves, everything transforms. We drift between the galaxies again through the immense darkness that separates them. This void, Nova explains, is not empty. It is filled with invisible gas, radiation, and dark matter. Unseen but powerful, dark matter forms the scaffolding of the universe, holding galaxies together, connecting them into the great web that spans the cosmos. Without it, the universe as we know it could not exist. As we float through the darkness, the faint light of distant galaxies glimmers in the background, each one a possible home for billions of suns. Nova's tone becomes poetic. If you were to count every star in the local group, one per second, it would take you longer than the entire history of human civilization to finish. And still, you would not be close to counting the stars in the universe. The camera slowly zooms out, showing the local group in its entirety, a small cluster of glowing galaxies, suspended like fireflies in infinite night. The Milky Way and Andromeda, side by side, form the dominant lights in the frame. Nova concludes, "We often think of galaxies as islands of light, isolated and alone. But in truth, they are part of something larger, a family bound by gravity, by time, and by the silent dance of creation." The screen darkens as the galaxies shrink into the distance, merging into a faint, luminous cloud.
Nova's voice fades gently. "This is our home beyond home, the local group."
From here, the true vastness of the universe begins to reveal itself, stretching far beyond imagination into realms where even light itself struggles to keep up with creation. The final image lingers a slow pullback through the cosmic darkness, showing the cluster dissolving into the great tapestry of galaxies beyond. Nova whispers one last thought. We have left our galaxy behind, and still we are nowhere near the edge. The universe, it seems, has no end, only deeper mysteries waiting to be seen. The blackness of space stretches in every direction, silent and endless. But as Nova's voice returns, a faint glow begins to emerge. Not a single star or galaxy, but a web of light spanning unimaginable distances. "Beyond our local group," she says softly, "the universe reveals its grandest structure, the cosmic web, a vast, interconnected network of galaxies, clusters, and voids that form the very skeleton of the cosmos." Slowly, the camera zooms out, revealing the web in its full glory. Billions of galaxies bound together by gravity, stretched across space like threads of glowing silk. The cosmic web is not random chaos. It is an intricate pattern of order born from the early universe, sculpted by invisible forces over billions of years. Each glowing filament in this web contains countless galaxies, while the dark spaces between them, the cosmic voids, are immense regions of near nothingness, spanning hundreds of millions of light years. Nova explains that to truly grasp the universe's structure, we must think beyond stars and galaxies. What we see as light is only a fraction of the whole. Dark matter, the invisible glue that makes up most of the universe's mass, forms the scaffolding upon which galaxies gather. Where dark matter is dense, gravity pulls ordinary matter together, creating galaxies and clusters. Where it is thin, vast voids remain empty. If the universe were a living organism, Nova says, dark matter would be its bones and galaxies its glowing cells. We drift through one of the glowing filaments. Thousands of galaxies cluster together, each spinning in silent motion. Nova describes how these filaments connect like cosmic highways, stretching for billions of light years. Between them lie the great voids, immense expanses, where galaxies are scarce and space is almost empty. One of the largest, the Boötes void, measures 330 million light-years across, so vast that if the Milky Way were placed at one end, it would take light more than 300 million years to reach the other side. As we move deeper into this vast structure, Nova explains how it all began. In the earliest moments after the Big Bang, matter was not evenly distributed. Tiny fluctuations in density, almost imperceptible, began to grow under gravity's influence. Over billions of years, these ripples became filaments, and the filaments became the web we see today. Computer simulations show this cosmic network evolving small clumps merging into clusters, clusters forming superclusters, and voids expanding between them. What we see now is a frozen moment in a process that continues even today. Nova's tone grows reflective. The cosmic web, she says, is the closest thing we have to seeing the universe's architecture, a map of creation itself. As she speaks, the camera glides along a glowing filament, moving through clusters of galaxies bound together by their mutual pull. These clusters are some of the largest structures in existence, containing thousands of galaxies and trillions of stars, all orbiting a common center of mass dominated by dark matter and supermassive black holes. Among them lies the Virgo cluster, our galactic supercluster's heart. Nova explains that it contains more than 1,300 galaxies, including massive ellipticals like M87, whose central black hole was the first ever imaged by humans. This single cluster alone spans over 15 million light-years, and its gravitational influence extends even farther. The Milky Way, though separated by 65 million light-years, is still drawn subtly toward it. This slow, gravitational drift is part of a grander motion. The asterisk, great cosmic flow, asterisk. She describes how all galaxies, including ours, move not only within their local groups, but as part of vast, collective motions through space. The entire Laniakea supercluster, which houses the Milky Way, flows toward a mysterious gravitational region known as the asterisk, great attractor, asterisk. No one knows exactly what it is, a concentration of mass so immense that it bends the paths of galaxies for hundreds of millions of light-years around it. It is as if the universe itself is being pulled towards something unseen, Nova whispers. As we glide through this region, galaxies swirl past like glowing embers caught in a current. Nova's voice deepens with awe. From this scale, even galaxies lose their individuality. They become part of a larger tapestry, threads woven into the fabric of space-time. Is reverpension? The visuals pull back farther still. Now, superclusters themselves become nodes in an even grander web, connected by thin bridges of galaxies surrounded by vast voids where there is almost nothing at all. The pattern is strikingly familiar, resembling neural networks in the human brain or the filaments of living tissue. Nova reflects on this cosmic symmetry. Perhaps it is no coincidence that the universe looks like the structure of our own minds. Maybe consciousness itself is a reflection of the same order that shaped the stars. She continues, describing how scientists study the large-scale structure of the universe using galaxy surveys like the Sloan Digital Sky Survey. Millions of galaxies are mapped, their positions plotted in 3 dimensions, revealing the same intricate web across billions of light-years. It is a cosmic fingerprint, showing how matter has organized itself since the dawn of time. Nova explains that even though the cosmic web appears static, it is alive with motion. Galaxies move, merge, and evolve. Superclusters drift apart as the universe expands. Over unimaginable timescales, the web itself stretches thinner, pulled by dark energy, the mysterious force accelerating the expansion of the cosmos. What we see now, Nova says quietly, is only a fleeting moment in a living, changing universe. Even these colossal filaments, spanning billions of light-years, are temporary patterns in an ever-expanding sea. The camera pans outward until the cosmic web fills the screen, an endless lattice of light suspended in darkness. Each point, each glimmer, represents billions of galaxies, each with billions of stars, each possibly with planets and life. Nova's voice softens. The cosmic web is the closest thing we have to seeing the universe's soul, a structure so vast and delicate that it defies imagination. Yet we are part of it. The atoms in our bodies were forged in stars that formed along these filaments. We are not separate from the universe. We are woven into its very fabric. As the perspective continues to widen, the web begins to fade into mist. The filaments become faint threads of light, merging into a diffuse glow, and finally into darkness. Nova pauses, and her final words for this chapter linger like an echo through eternity. We began our journey on a single planet, orbiting a single star. We have now seen the grand design that holds everything together, the cosmic web. It is the architecture of creation, a bridge between the visible and the invisible. And yet, even here, we have not reached the edge. The universe continues far beyond stretching into distances that light itself can barely cross. The screen fades to black, and the stars vanish, leaving only a faint hum, the sound of silence echoing through the infinite, waiting for the next chapter of the journey. The darkness feels infinite now. For a moment, there is nothing, no stars, no galaxies, just a faint background glow. Nova's voice breaks through, low and steady. We have reached the very edge of visibility. This is the boundary of everything we can see, the edge of the observable universe. Slowly, the faint glow sharpens into a sphere, the cosmic horizon. Beyond it lies a realm we can never touch, never see, never know. Nova explains that this edge is not a physical wall, but a limit defined by time and light. Because the universe has existed for 13.8 billion years, we can only see light that has had time to reach us since the beginning. Anything farther away is invisible, its light has not yet arrived. As she speaks, we zoom inward from the horizon, moving through layers of cosmic time. Each layer represents an era in the universe's history, a snapshot frozen in light. Closest to the edge are the oldest photons relics from the moment the universe became transparent, known as the cosmic microwave background. These photons have been traveling for over 13 billion years, stretching and cooling as space expanded. What began as blinding fire now lingers as a faint microwave whisper, the afterglow of creation itself. Nova's voice softens. The cosmic background is the oldest light we will ever see, the echo of the Big Bang. It carries the imprint of the universe's birth, a message written in radiation telling us where we came from. The visuals fill with a shimmering sphere of faint light, mapped by satellites like Planck and WMAP. Tiny fluctuations in its glow mark the seeds of everything that would one day exist. The galaxies, the stars, the worlds, and life itself. As we move inward from this edge, Nova explains that the light we see from distant galaxies is not a glimpse of their present, but their past. The farther we look, the younger the universe becomes. When we observe galaxies 10 billion light-years away, we see them as they were 10 billion years ago. They appear smaller, dimmer, less developed. At the furthest reaches, we see galaxies just beginning to form fragile clusters of stars surrounded by swirling gas. Nova describes how the universe itself has expanded during this time. Space is not a static stage, it stretches, carrying galaxies with it. The farther something is, the faster it appears to move away from us, a discovery made by Edwin Hubble in the early 20th century. This expansion means that some regions of the universe are now so far away that their light will never reach us. They are receding faster than light itself, not because they are moving through space, but because space itself is expanding between us. When we speak of the edge of the observable universe, Nova says, we are really speaking of time, the age of light. We are seeing 13.8 billion years of cosmic history compressed into a single view. The camera now pulls back, revealing the observable universe as a glowing sphere surrounding Earth at its center. Nova explains that this does not mean we are in a special place. Every observer, anywhere in the universe, would see themselves at the center of their own observable sphere. The universe has no true center. It expands uniformly everywhere. As the sphere turns, we see galaxies, clusters, and filaments forming patterns that stretch across the cosmos. The most distant galaxies appear as faint red smudges, their light stretched by the expansion of space, a phenomenon known as redshift. Nova describes how astronomers measure this redshift to determine how fast galaxies are moving away, allowing them to map the history of cosmic expansion. At the farthest edge, we reach the moment before light, the cosmic dark ages. Here, the universe was still opaque, filled with dense gas that blocked all radiation. No stars yet burned, no galaxies yet shone. Nova's voice drops to a whisper. This was the time before light, before structure, before creation took shape, a universe in waiting. Then, in a slow, breathtaking sequence, the first stars ignite. Tiny, brilliant points flicker in the darkness, illuminating the void. Nova explains that these were the population 3 stars, the first generation, made entirely of hydrogen and helium. They were massive, unstable, and short-lived. But their light marked the end of darkness. Their deaths created the first heavy elements, seeding the universe for future generations of stars and planets. As the scene unfolds, billions of years pass in seconds. Galaxies begin to form, merging and growing. Clusters take shape, filaments stretch, and voids expand. The cosmic web, the very structure we saw before, begins to emerge. Nova narrates this evolution with quiet wonder. From a single flash of creation, an entire universe unfolded. It has grown, expanded, and evolved for nearly 14 billion years. And yet, even now, it is still becoming.
We move back toward the present, watching as galaxies mature and collide. Some form giant elliptical shapes, others remain spirals like our own.
Quasars flare at their centers, brilliant beacons powered by supermassive black holes, consuming matter at terrifying speeds. Their light, brighter than entire galaxies, travels across billions of years to reach us. Nova pauses. When we look at the edge of the observable universe, we are not looking outward. We are looking backward into the deep past. The light that surrounds us is a record of everything that has ever been. Easting. The visuals fade into a slow rotation of the observable universe. A glowing sphere filled with patterns of galaxies, clusters, and filaments, all suspended in blackness. Nova's voice turns reflective, almost meditative. Beyond this edge lies the unobservable universe, regions we will never see, no matter how long we wait. They are not beyond space, but beyond time. Their light will never reach us, for the universe expands faster than it can travel. The camera zooms out one final time, showing the observable sphere shrinking against the black infinity beyond. Nova's tone becomes soft and reverent. We live inside a cosmic bubble of light, surrounded by the unseen. Everything we know, every star, every galaxy, every atom that has ever existed, all of it fits within this fragile sphere. And beyond it, Silence, a silence that may go on forever. She pauses, and the screen fades to darkness. Only a faint hum remains, like the echo of the Big Bang itself. The edge of the observable universe, Nova whispers, is not the end of the universe. It is only the beginning of what we cannot yet imagine. As her voice fades, the final image appears a faint glow, expanding slowly into infinite black. The universe continues, endlessly growing, endlessly becoming, beyond the horizon, beyond the reach of light, beyond even our deepest dreams. The silence of deep space surrounds us again, endless and motionless. Then Nova's calm voice returns, almost as if carried by the faint echo of the cosmos itself. The universe is not still, she begins softly. It breathes, it expands. The space between galaxies stretches wider every second, carrying them farther apart, a motion that has never stopped since the moment of creation. Histekit, this is the story of cosmic expansion, one of the most profound discoveries in human history. The screen fills with a vision of galaxies drifting slowly away from one another, glowing islands of light moving in all directions. Nova explains that this expansion is not like an explosion hurling matter into empty space. Rather, space itself is stretching, expanding, like an inflating balloon. The galaxies are not moving through space. The fabric of space itself is expanding, and they move with it. Nova recounts how this idea was first glimpsed a century ago, when astronomer Edwin Hubble studied distant galaxies and noticed something remarkable. Their light was red-shifted, stretched toward longer wavelengths. This meant they were moving away from us, and not just a few, but all of them. The farther a galaxy was, the faster it appeared to recede. This relationship, now known as Hubble's law, revealed a universe in constant motion. The visuals show light waves stretching as galaxies drift apart. Nova explains how this redshift is not caused by physical speed, but by the stretching of space itself. The expansion does not happen into anything, it simply is. Every region of the universe sees the same effect, no matter where the observer stands. From every galaxy, it seems the universe is expanding away, Nova says. There is no center and no edge. The expansion happens everywhere at once. As she speaks, the camera zooms out through billions of galaxies. The scale increases with every passing second, and soon the galaxies themselves become mere points of light. Nova explains how the rate of expansion is not constant. After the Big Bang, gravity began to slow it down. Galaxies pulled at one another, trying to resist the outward flow. But then something unexpected happened. Instead of slowing, the expansion began to accelerate. Something unseen is driving the universe apart, Nova says quietly. Something vast, powerful, and invisible. Scientists call it dark energy, a mysterious force that makes up nearly 70% of the universe. No one knows what it truly is. It could be a property of space itself, a kind of energy woven into the fabric of reality, or it could be something deeper, a cosmic pressure pushing against gravity's pull. As Nova narrates, we watch galaxies drifting faster, their light stretching farther into red until it fades from sight. Distant galaxies slip beyond visibility, disappearing forever into the darkness. Each second, Nova says, the universe loses a little more of itself. The most distant galaxies are already beyond reach. Their light will never reach us, no matter how long we wait. A haunting pause follows. This is the ultimate horizon, Nova whispers. A boundary that grows with time. As the universe expands, more and more of it slips beyond our view. One day, billions of years from now, the night sky will be empty. No galaxies, no stars beyond our own. The universe will appear dark, silent, and infinite once more. The visuals now transform into a cosmic timeline, Nova guides us through it. In the early universe, galaxies were packed close together, their light brilliant and blue. As time passed, the expansion slowed briefly, allowing galaxies to form, merge, and grow. But as dark energy began to dominate, the expansion accelerated. Now, billions of years later, galaxies are spreading apart faster than ever before. Nova explains how scientists measure this acceleration by observing distant supernovae exploding stars that act as cosmic mile markers. Their brightness reveals how quickly the universe has been expanding over time. Through these observations, astronomers have confirmed the existence of dark energy, an invisible force shaping the cosmos on the largest possible scale. We don't yet understand what dark energy is, Nova continues, but we know what it does. It stretches the fabric of space itself. It pushes galaxies apart, and one day it will define the fate of everything. As she speaks, the camera drifts into a simulation of the future. Billions of years pass in seconds. Galaxies pull away from one another, leaving vast emptiness between them. The universe grows colder, darker, lonelier. Only small clusters remain bound by gravity, the last remnants of the cosmic web. Eventually, even these fade into isolation, their light redshifted into invisibility. Nova's tone becomes almost sorrowful. The farther we look, the faster we see the universe escaping us. It is as if creation itself is slipping through our fingers. And yet, in this endless expansion lies beauty, the story of change, of growth, of time unfolding without end. But not all is lost. Nova reminds us that this expansion is also the reason we exist. If gravity had been too strong, the universe would have collapsed back into itself. If expansion had been too rapid, galaxies and stars could never have formed. Somewhere in between those extremes lies the delicate balance that allowed life to emerge. We are here, Nova says, because the universe expanded just right. The visuals return to a panoramic view, galaxies glowing softly in the blackness, stretching outward in every direction. Nova's voice deepens with quiet awe. This expansion connects everything. It links the past to the future, the birth of atoms to the death of stars. It is not merely motion, it is the rhythm of existence. As the scene slows, a single photon of light drifts across the screen, moving endlessly through expanding space. Nova continues. Every photon, every wave of light stretches as the universe grows. The farther it travels, the longer its wavelength becomes until it fades into darkness. Even light cannot outrun the expansion. She pauses, her voice almost a whisper. This means the universe will never stop growing. Its edge will move faster and faster, until most of what exists lies forever beyond reach. What we see today, this cosmic ocean of galaxies, is only a small moment in its history. The camera pulls back one final time, revealing the universe as a vast, expanding sphere of faint light. The galaxies drift farther apart, their glow dimming, their colors reddening, until only the faintest embers remain. Nova concludes softly. We live in an expanding universe, a universe that is both infinite and fragile, eternal and fleeting. The stars we see tonight are reminders of what was and what will someday vanish beyond the horizon of time. The universe grows not because it must, but because it can. It is the nature of existence to expand, to move, to become. The final image fades to complete black, and for a moment there is nothing, only the faint hum of creation itself, stretching endlessly into forever. The darkness deepens again, infinite and eternal. Nova's voice returns, this time slower, contemplative, the tone of someone standing before the unknowable. "We have followed light to the farthest edge of the visible cosmos," she says softly. But a question remains. Does the universe end there, or does it go on forever? The camera begins to drift through the faint haze of galaxies, billions upon billions of them, their light thinning into the distance. Beyond this visible boundary lies a mystery that has haunted astronomers and philosophers alike. Is the universe finite or infinite? Is there an edge, a boundary where space simply stops? Or does it continue endlessly beyond the reach of light and time? Nova explains that to answer this question, we must first understand what infinite means in the language of the cosmos. Infinity is not simply large, it is without limit. If the universe is infinite, then no matter how far you travel, you would never reach the end, for there would be no end. It would continue forever, filled with galaxies, stars, and perhaps even countless versions of ourselves, scattered across endless space. But if the universe is finite, then it must have a shape, not a wall or an edge, but a curvature. Nova describes it like this. Imagine the surface of the Earth. If you walk in a straight line long enough, you eventually return to where you began. The Earth has no edge, yet it is finite. In the same way, space itself could be curved. If you could travel far enough through the cosmos, beyond galaxies, beyond time, you might someday arrive back where you started without ever crossing an edge. As she speaks, the visuals show a vast 3D grid of stars curving subtly into itself, bending into a cosmic loop. The universe might be like this, Nova says, a higher dimensional sphere, endlessly wrapping around itself. Scientists call this the topology of the universe, the geometry that defines its overall shape. Some evidence suggests that space may be nearly flat, meaning it extends without curve or end. Others believe it is slightly curved, implying that it could loop back upon itself in unimaginable ways. But no telescope, no observation has yet revealed the full truth. We see only a small piece of the infinite puzzle. Nova's voice lowers, filled with wonder. If the universe truly has no end, then somewhere, unimaginably far away, the patterns of galaxies could repeat. The same arrangement of stars, the same constellations, the same planets, and somewhere in that repetition, you could be looking up at another sky, asking the same question, how big is the universe? As she speaks, the camera pans across an endless cosmic landscape, galaxies repeating in fractal patterns, stretching into forever. But then the image warps, bending inward, suggesting a curvature that brings the scene back around upon itself. Perhaps infinity, Nova muses, is not a line that goes on forever, but a circle too vast to perceive. We move deeper into the science of it. Nova explains how cosmic background radiation, the faint afterglow of the Big Bang, offers clues to the universe's shape. Scientists have mapped this radiation across the sky, searching for signs of curvature, for hints that light has wrapped around the cosmos. If the same pattern appeared in multiple directions, it would mean space folds back upon itself. But so far, the universe appears remarkably smooth and uniform, suggesting it might truly have no boundary. She pauses. But even if it is infinite, that does not mean we can see it. Our observable universe is limited by the speed of light and the age of time itself. Everything beyond that remains hidden, not because it isn't there, but because we cannot yet know it. The visuals fade into an endless sea of stars, the camera gliding through them as Nova continues. If the universe is infinite, then there are infinite galaxies, infinite stars, infinite worlds. Somewhere there could be another Earth, orbiting another sun, identical in every way. and somewhere beyond that, another and another. Infinite possibilities, repeating forever. But the idea of infinity also carries something haunting, a sense of unreachability. Nova's voice turns quiet, almost somber. In an infinite universe, we are both eternal and insignificant. No matter how far we go, there will always be farther. No matter what we discover, there will always be more. Infinity is not comfort, it is humility. As she speaks, the galaxies around us begin to blur, blending into a glowing mist. The light stretches into endless waves of color, forming a soft cosmic fog. Nova continues. Perhaps the greatest mystery is not whether the universe ends, but whether it ever truly began. If space and time are infinite, then there was no first moment, only change, transformation, and the eternal unfolding of existence. She reminds us that some cosmological models propose a cyclic universe, one that expands, contracts, and expands again, forever reborn from its own ashes. In this vision, the Big Bang was not the beginning of everything, but just the latest breath in an infinite rhythm of creation. Other theories suggest that the universe could be part of a far larger structure, a single bubble among countless others in a cosmic sea. If this is true, Nova says, then our universe may be infinite, not within itself, but within an infinite collection of universes. The visuals shift to an awe-inspiring scene. Billions of glowing spheres, each representing a separate universe, drifting in an endless void, their light faint but eternal. They ripple and merge like bubbles in a vast cosmic ocean. This, Nova whispers, is the multiverse, the possibility that our universe is one of many. And if that is true, then even infinity itself might only be the beginning. The music swells softly, almost melancholic. The camera pulls back, farther than ever before, past galaxies, past filaments, past every structure imaginable, until all of creation becomes a faint shimmer of light. Nova's voice fades to a near whisper. We may never know the true size of the universe. Perhaps it ends, perhaps it does not. But the question itself is what defines us to ask, to wonder, to reach beyond what we can see. Oscar. The final image shows a single star flickering in the dark, surrounded by infinite emptiness. Maybe infinity, Nova concludes, is not something to be measured. Maybe it is something to be felt in the silence between the stars, in the endlessness of time, in the part of us that refuses to stop looking. The light fades completely, leaving only darkness. For a moment, there is no sound, just the quiet echo of infinite space, vast beyond thought, waiting for the next revelation that lies beyond the reach of light. The screen fades into darkness once more. Galaxies vanish, stars dissolve, and we're left with a quiet, black infinity until Nova's calm, reflective voice returns. What if, she says slowly, our universe is not the only one? A faint glimmer appears, spreading into a glowing bubble of light. Then another, and another. Soon, the darkness fills with countless luminous spheres, universes floating together in an unseen cosmic ocean. This, Nova continues, is the multiverse a possibility so vast it challenges the meaning of everything we think we know. She explains that the multiverse is not just a theory born from imagination. It emerges from the deepest questions in physics and cosmology. If the Big Bang created our universe, what created the Big Bang? What happened before time began? And could there have been other Big Bangs, other universes, born from the same cosmic fabric? Nova's voice carries the tone of both science and wonder. If our universe began from inflation, a burst of rapid expansion that stretched space itself, then that inflation may not have been unique. It may have happened again and again in endless pockets of the greater cosmos. Each one became a separate universe, each with its own laws, its own constants, its own reality. As she speaks, the visuals unfold into an awe-inspiring vision of eternal inflation, an endless foam of universes expanding and budding off from one another like bubbles in boiling water. Some glow faintly, some burn bright, others flicker and vanish. In this view, Nova explains, our universe is just one bubble among countless others, one region of space where the cosmic expansion slowed enough to allow galaxies, stars, and life to form. She continues, inside each universe, the laws of physics might be different. The strength of gravity, the behavior of light, even the nature of time itself could change. In some universes, stars might never ignite. In others, gravity might be so strong that no galaxies can exist at all. Perhaps only in this one. The balance was just right for life to emerge. The screen drifts through these glowing spheres, passing through their boundaries into entirely different realities. Some universes shine with blue-white brilliance, others pulse with crimson light. Some seem frozen in motion, others flicker chaotically like a flame. If we could travel between them, Nova says, we might find infinite diversity, infinite forms of existence. Every possible version of reality, every possible history could exist somewhere out there, beyond our cosmic horizon. But she pauses, her tone softens, thoughtful. We cannot see these universes. We cannot touch them. They lie forever beyond our reach. Yet the equations of physics, the mathematics that describe our own universe, whisper that they may be real. The visuals shift to the quantum-level waves of energy, flickering and colliding in a shimmering void. Nova explains how even quantum mechanics, the science of the smallest scales, hints at other realities. In the quantum world, every event can have multiple outcomes. Some theories suggest that each outcome happens not in this universe, but in others. Every decision, every chance, every path not taken exists somewhere else in another branch of reality. As she speaks, the camera divides again and again, countless versions of the same scene splitting off like reflections in an endless mirror. Each one slightly different, each one its own universe. This is the many worlds interpretation, Nova continues. In it, reality is not singular, but infinite, a branching tree of possibility that never stops growing. She lets the silence linger, and then her voice softens. The multiverse may sound impossible, yet so did the idea of galaxies once. So did the expansion of the universe. Every discovery that has ever changed us began as something unimaginable. The visuals fade into a wide cosmic view, all the bubbles of universes floating together in the great unknown. Some collide, merging into luminous waves of energy. Nova describes how, if universes ever touched, they might leave scars, faint imprints in the cosmic microwave background, like fingerprints of other realities pressing against our own. Scientists have searched for these clues, she says, but so far, none have been found. Still, the search continues, driven by curiosity and the unshakable human need to understand. Nova's tone deepens. If the multiverse exists, it changes everything. It means the universe we know is not the whole story, only one page in an endless book. It means there could be other versions of you, living other lives under different stars. It means that what we call reality might be only one reflection in an infinite mirror. As her words echo, the visuals zoom outward. The bubble universes shrink until they become points of light, filling the screen like stars, each one an entire cosmos. The image transforms into something beyond scale, beyond imagination. And yet, Nova says, even if there are infinite universes, they may still share one origin. Perhaps they all come from the same source, a single, timeless reality from which everything, even existence itself, was born. The light begins to fade, leaving only one glowing sphere, our universe. Nova's voice turns quiet, almost like a whisper carried by time. We may never know for certain whether the multiverse is real. We may never see beyond our cosmic horizon, but in asking the question, we remind ourselves of what makes us human, the need to wonder, to reach, to imagine. The camera slowly zooms in toward the single glowing sphere, our universe, floating in infinite black. Whether there are many universes or only one, Nova concludes, the truth is the same. We are part of something far greater than ourselves, something eternal, beautiful, and infinite. The final image lingers a single point of light, glowing softly against the void. It flickers once, like the last breath of a star, then fades into complete silence. Nova's last words echo faintly, fading into the darkness. Perhaps the question is not how big the universe is, but how deep our imagination can go. The blackness stretches endlessly, but now, out of the silence, a faint pulse appears, a flash of light, then another, then a cascade of shimmering waves. Nova's voice emerges once again, soft yet filled with gravity. Light, she says, is the thread that connects everything. It is how the universe speaks to us across space, across time. This is the story of light, time, and perspective. The way light carries the memory of the universe, the way it defines distance, and the way it allows us to see the past written in the sky. As the scene unfolds, we see photons, particles of light, traveling through the cosmic void, crossing billions of light years, untouched by time or gravity. Every ray of light you see tonight, Nova says, is ancient. The light from the sun took 8 minutes to reach you. The light from the nearest star took over 4 years. And the light from the most distant galaxies began its journey long before the Earth existed. The visuals shift to a breathtaking view of deep space, distant galaxies, nebulae, and quasars glowing faintly, their light stretched thin across the ages. When you look at the sky, Nova explains, you are not seeing what is, you are seeing what was. The farther you look, the older the light becomes. Telescopes are not instruments of sight, they are instruments of time. The camera pans slowly toward a galaxy cluster billions of light years away. Nova explains how telescopes like Hubble and James Webb allow us to peer deep into the past, capturing the faint light of galaxies formed less than 1 billion years after the Big Bang. These are cosmic fossils, she says, ancient messages traveling through the expanding fabric of space, reaching us after an unimaginable journey. The imagery transitions to an artist's depiction of the James Webb Space Telescope drifting silently in orbit, its golden mirrors unfolding like petals. Nova describes how this telescope, unlike any before it, sees in infrared a wavelength stretched by time and distance, allowing it to detect light too old and too faint for human eyes. Through it, Nova whispers, we see the universe as it once was, young, chaotic, and full of promise. The visuals now shift between galaxies of different ages, some massive and mature, others small and fragile. Light reveals the story of evolution. Nova continues. From the first stars that ignited after the cosmic dark ages to the great spirals that now fill the universe, every photon carries a piece of history, a memory from the dawn of time. Nova explains how even light bends under gravity, how massive objects like galaxies and black holes can warp space, curving the path of light itself. The screen shows a breathtaking simulation of gravitational lensing distant galaxies, appearing as stretched arcs and rings around invisible centers of mass. Space is not flat, Nova says. It bends, and light follows its curves. What we see in the sky is not always where it truly is. We zoom into a region of space where multiple distorted galaxies appear around a single glowing cluster. Nova describes how scientists use these distortions to map the presence of dark matter, the unseen mass that shapes the universe. Light shows us what is hidden, she says. By following its path, we find what we cannot see. As the narration continues, we transition from cosmic scales to the flow of time itself. Nova's tone becomes softer, almost poetic. Light does not age, she says. For it, time stands still. A photon that left a distant galaxy billions of years ago experiences no passage of time. It is as new now as the moment it began. But for us, that same light is ancient. It reminds us that time is not absolute. It is woven into space, stretching and bending with gravity. The visuals shift to show the warping of space-time around a massive star, a grid bending under its weight. Nova explains how time flows differently in different places. Near a massive object, time slows. In empty space, it flows faster. The universe is not a clock, it is a river, with currents and eddies shaped by mass and motion. She continues, "This means that every moment you experience is relative. Your heartbeat, your breath, your life, they are all bound to the curvature of space-time. Even the ticking of a clock on Earth runs differently from one in orbit, because time itself is stretched by the pull of gravity. The scene changes to a brilliant view of a supermassive black hole, its accretion disk swirling with light. Nova explains that near the edge of such an object, time slows almost to a stop. To an outside observer, light from matter falling into a black hole appears frozen at the edge. But from within, it continues beyond what we can ever see." She pauses, and the camera slowly pulls back from the black hole, through the galaxy, back into open space. Light, time, and perspective are the same story, Nova says. To see is to look backward. To measure distance is to measure time. And to understand the universe is to realize that everything we observe, every star, every galaxy, is already history. As her voice continues, the screen fills with overlapping timelines, images of stars being born, galaxies colliding, civilizations rising and falling, all connected by beams of light stretching through space. The universe is not a snapshot, Nova says. It is a film still playing, every frame connected by light. Then, softly, she reflects. And here we are, small beings made of stardust, using light to understand our origins. We live in the present, but we see the past. Every night, when we look at the stars, we are witnessing ghosts, the memory of the cosmos shimmering across time. The final visuals fade into a slow pan of the night sky. Millions of stars glowing above a silent Earth. Nova's tone is serene, almost meditative. Light is our messenger, she says. It is the bridge between what is and what was. Through it, the universe speaks across billions of years, across endless space, across the silence of eternity. As her words fade, the stars in the sky begin to dim, one by one, until only a single beam of light remains, cutting through the darkness. Light is not just what we see, Nova whispers in the closing line. It is the universe remembering itself. Wait. The screen fades to black, leaving only a faint eternal shimmer, as if the last photon from the beginning of time were still traveling, forever carrying the story of existence through the infinite night. Darkness fills the screen once more, deep, endless, and absolute. But from this infinite black faint threads of light begin to emerge, weaving together like invisible strands of a web. Nova's voice returns, low and steady, as if speaking from within the fabric of space itself. What we can see, she begins, is only a tiny fraction of what exists. Most of the universe is hidden, invisible, silent, yet unimaginably powerful. It is made not of stars and galaxies, but of mysteries we cannot touch or see. This is the story of the unseen universe, of dark matter and dark energy. As the faint light builds, the camera zooms through the cosmic web, where bright galaxies sit like beads on glowing filaments. Between them lies a great void, filled with nothing visible. Nova continues. Everything we know, every planet, every star, every molecule, makes up less than 5% of the universe. The rest, 95%, is invisible, yet it shapes everything. The visuals shift, the glowing filaments fade, revealing the faint gravitational framework of dark matter, an unseen substance surrounding galaxies like a ghostly halo. Nova explains how scientists first discovered its presence in the 1,930 seconds. Astronomers noticed that galaxies rotated too quickly, so fast that by ordinary physics they should have torn themselves apart. There had to be something more, something massive and invisible holding them together. That hidden mass, Nova says, is what we now call dark matter. As she speaks, the camera moves through a spiral galaxy. We see stars orbiting faster than the light from their mass can explain. Invisible tendrils of dark matter stretch outward, forming a structure that binds everything in place. Dark matter has no color, no light, no reflection, Nova says. It passes through you, through stars, through entire planets, without ever colliding. Yet without it, galaxies could not exist. We could not exist. The visuals shift to a massive simulation, a universe made entirely of dark matter. It glows faintly in false color, revealing a cosmic skeleton. The pattern mirrors the structure of the real universe, with filaments, clusters, and voids. Nova explains that dark matter acts as the scaffolding of the cosmos, pulling gas and dust together to form stars and galaxies. Where there is dark matter, she says, light follows. Where there is none, space remains empty. Scientists have searched for its identity for decades, particles that might explain this invisible mass. Theories suggest that dark matter could be made of exotic particles like WIMPs, axions, or sterile neutrinos particles beyond the standard model of physics. But so far, every experiment has come up empty. We have built detectors deep underground, Nova says. We have sent telescopes into orbit, yet dark matter remains silent, unseen, untouchable. The camera glides through a laboratory buried beneath mountains, massive detectors surrounded by liquid xenon waiting for a single collision with a dark matter particle. Nova's voice is calm but heavy with awe. In that silence, she says, we hear the universe keeping its secrets. As we move farther into the cosmic view, another unseen force begins to reveal itself: dark energy. The screen expands outward, showing galaxies drifting apart. If dark matter holds the universe together, Nova explains, then dark energy tears it apart. It is the invisible pressure pushing galaxies away from one another, accelerating the expansion of the universe. The visuals show galaxies slowly receding, their light stretching and fading into red. The pace quickens. Nova's tone becomes almost haunting. No one knows what dark energy truly is. It might be a property of space itself, an energy that increases as space expands. Or it might be something deeper, a force born from dimensions we cannot yet see. She pauses, and the music fades into a low, cosmic hum. Together, dark matter and dark energy make up 95% of everything: the universe, We see the stars, the planets. The light is just the surface of a vast hidden ocean. The screen transitions to a sweeping view of the cosmic web again, this time showing two layers. The visible universe, glowing faintly, and beneath it an even larger shadow structure of dark matter and energy.
We live inside this invisible architecture, Nova says. Every galaxy, every atom, every breath we take is shaped by forces we cannot see.
The visuals dissolve into a simulation of the universe's evolution. We watch as tiny fluctuations in the early cosmos grow into filaments and clusters under the pull of dark matter. Then, slowly, dark energy begins to dominate, stretching everything outward, diluting the web itself. The universe, Nova explains, is a struggle between two great forces, one that gathers and one that separates, between gravity, which unites, and dark energy, which divides. Her tone grows quieter, more intimate. We exist in the moment between those forces, balanced in the fragile pause between creation and isolation. One day, dark energy will win. Galaxies will drift so far apart that their light will never reach one another. The universe will become dark again. As she speaks, the visuals fade to a haunting scene of isolation, a single galaxy floating alone in endless black, the last island of light in a dying cosmos. But that ending, Nova whispers, is written in forces we can barely comprehend. Our story is still unfolding, carried by the invisible currents of the universe. She pauses for a long moment. The screen glows faintly again, showing the faint outline of the cosmic web unseen, yet everywhere. Dark matter and dark energy remind us that most of reality is hidden. What we see is not the whole picture, only the reflection of something far greater. The music swells softly, like the echo of a heartbeat. Nova concludes, her voice serene and steady. The unseen universe is not emptiness. It is the foundation of everything. It binds the galaxies, drives creation, and shapes destiny. It is the invisible soul of the cosmos. The final image shows a faint, glowing thread stretching across the screen, a single line of light connecting two distant galaxies, shimmering against the black. As it fades, Nova's last words linger. We may never touch the invisible universe, but every atom of our being moves in harmony with it. We are the seen and the unseen, the light and the shadow that gives it form. The screen fades to black once more, and the faint hum of the cosmos returns quiet, eternal, and unseen. The screen opens to silence. A pale blue glow slowly emerges, swirling like mist across an infinite void. Nova's voice enters softer this time, weighted with humility. After all our searching, after mapping galaxies and measuring the expansion of the cosmos, we've reached the edge of what we can know. Beyond this lies mystery, not of space, but of understanding. This is the limit of human perception. As the scene fades into a slow panorama of galaxies, Nova continues. For centuries, we have tried to see farther, to build better instruments, to decipher the code of creation. And every time we thought we reached the end, the universe revealed another horizon. But now, we face a boundary, not of distance, but of knowledge itself. The camera zooms outward, showing telescopes orbiting Earth Hubble, James Webb, Chandra, their golden mirrors, staring into infinite darkness. Nova explains how these instruments, though remarkable, capture only fragments of truth. Light can only tell us so much. Our tools are bound by physics, our senses by biology, and our imagination by what we have seen. Beyond those limits lies a universe we cannot yet describe. She speaks of human limitation not as a flaw, but as a defining beauty. We are tiny, fragile beings trying to comprehend infinity, she says. Our minds evolved to count stones, not galaxies, to survive the night, not to measure it, and yet, somehow, we reached for the stars. The visuals drift toward a quiet image of Earth, small and glowing in the darkness. Nova's tone becomes personal, almost human. This tiny planet is the only place we can truly know. Every telescope, every theory, every dream of the cosmos begins here, with minds made of the same atoms that form the stars. We zoom back into deep space, where the galaxies shimmer faintly like sparks of thought. Nova reflects on how even the most powerful minds from Galileo to Einstein struggled against the same wall of ignorance. Each discovery brings clarity, she says, but also confusion. For every question answered, 10 more appear. The closer we come to truth, the farther it moves away. The visuals shift to a montage of humankind's pursuit of cosmic knowledge, cave paintings of the night sky, the first telescopes of the Renaissance, the equations of relativity, the launch of satellites and rovers. Knowledge is motion, Nova says. We move forward not because we know, but because we don't. The tone becomes philosophical. Perhaps the universe is not meant to be fully understood. Perhaps its immensity exists to remind us of our limits, to keep us humble before the infinite. The screen fills with an image of a swirling nebula, vibrant and alive. And yet, Nova continues, it also reminds us of our potential. We may be small, but we are part of the same story, made of the same matter, following the same laws, sharing the same fate. The scene fades into an immense black expanse dotted with faint galaxies. Nova explains how, even with all our technology, there are regions of the cosmos forever beyond our reach, not because they don't exist, but because light from them will never reach us. We are surrounded by silence that will never break, she says. Whole galaxies, entire universes, lost to us forever. Their light stretches endlessly away, too faint to ever return. She pauses. And still, we imagine. We build models. We dream equations. We simulate realities that may never be seen. That, perhaps, is what makes us remarkable, our refusal to stop asking. The visuals now show a group of scientists looking through telescopes, coding, sketching theories, and watching data streams from distant galaxies. We are explorers, Nova says. Not of planets, but of possibilities. Every calculation, every observation is an act of hope, a belief that even in the face of infinity, meaning can be found. Her tone grows more intimate. But there is another kind of knowledge, one that does not come from measurement or proof. When we look at the stars, we feel something wordless, a recognition that we are part of it. That the same energy that fuels galaxies burns quietly within us. The visuals slow, revealing the faint outline of the human eye reflecting starlight. Perhaps the universe doesn't need us to understand it, Nova says. Perhaps it only needs us to witness it, to be aware, for a fleeting moment, that existence itself is possible. The music softens into a quiet hum. Nova reflects on the irony that the more we learn, the smaller we feel, yet the more connected we become. We are not separate from the universe. We are its awareness, briefly illuminated by consciousness. The cosmos looks at itself through our eyes. As her words fade, the visuals expand outward again, showing the universe from its smallest to largest scales: atoms, stars, galaxies, superclusters, and the cosmic web, all connected in a single flowing motion. The limit of understanding, Nova whispers, is not the end. It is the beginning of wonder. It is where knowledge becomes awe. A long silence follows. The camera pans across the night sky, filled with billions of faint points of light. Then Nova speaks once more, slowly and gently. We may never know everything, but to try to look up and ask why that is enough, that is what it means to be alive in a universe like this. The final image fades to black, leaving only a faint blue glow Earth, distant and fragile, suspended in eternity. Nova's last words linger softly. The universe is not meant to be conquered. It is meant to be contemplated. And in that contemplation, we find ourselves small, temporary, but infinite in our curiosity. The screen fades to silence the sound of thought itself, dissolving into the eternal quiet of space. Darkness settles again, vast and absolute. For a moment, there is only silence, the kind of silence that feels ancient. Then Nova's voice emerges, slow and solemn. We've journeyed through the beginning, the expansion, the structure, and the unseen. But even the universe must face its end. Everything that begins must one day fade. This is the story of what comes next, the fate of the universe. Wait. The screen glows softly, revealing a slow drift of galaxies, their light dim and red, stretched thin by expansion. The universe, Nova says, is growing colder. The stars that burn today are fewer than yesterday. In the future, there will be no new ones. As the visuals move through galaxies, Nova explains how the cosmic clock ticks forward into deep time. Trillions of years from now, the last stars will exhaust their fuel. Their light will fade, their heat will die, and darkness will return. She pauses, then continues. Scientists call this the heat death of the universe, a future where all energy is evenly spread and no motion, no light, no life remains. The imagery shifts to a dying star, its core collapsing, its light fading into red embers. Nova describes how small stars, like red dwarfs, will burn for trillions of years, far longer than the sun. But eventually, even they will cool into dark, frozen remnants called black dwarfs. For a time, Nova says, the universe will be filled with the silent glow of the last stars, like candles burning in an endless night. And then, one by one, even those will go out. The camera pulls back to reveal an ocean of black dwarfs, cold, invisible worlds scattered across infinite black. When the last star dies, Nova continues, the universe will no longer shine. Galaxies will fade into darkness, and space itself will grow colder, reaching a temperature barely above absolute zero. She pauses again, her voice softer now. But even then, the story does not end. Black holes will remain the great engines of gravity that devour light and matter. The visuals shift to a colossal black hole at the center of a dying galaxy, its accretion disk dim and ghostly. Nova explains how, over unimaginable spans of time, black holes will consume whatever matter remains, stars, planets, even other black holes, but not even they are eternal. After countless eons, she says, they too will fade, evaporating into nothing through a slow whisper of energy, a process called Hawking radiation. The screen fades into the blackness of space once more, punctuated by faint flashes of evaporating black holes. Nova continues, one by one, the great beasts will vanish. What remains will be a quiet sea of particles, cold, dark, and motionless. This is the long twilight of the cosmos. But not all theories agree. Nova's tone shifts, curious, almost hopeful. Some scientists believe the universe could meet a different fate, one of collapse or rebirth. She describes the Big Crunch, a scenario where gravity eventually overcomes dark energy, pulling everything back together. Galaxies reverse course, space contracts, and all matter converges into an incomprehensible point. In that final instant, Nova says, time itself would collapse, and perhaps from that singularity a new universe could be born, a new beginning hidden within the end. The visuals show a simulation of galaxies reversing, collapsing toward one another until all light converges into a single blinding flash. The end could also be the beginning, Nova whispers. The universe may not die, it may breathe. Then she introduces another possibility. The big rip in this terrifying vision, dark energy grows stronger with time, pulling galaxies apart faster and faster until it rips apart atoms themselves. If dark energy increases, Nova explains, it will not stop at galaxies. It will tear stars, planets, and even the fabric of space into fragments. In the final moment, not even particles will remain intact. The visuals distort and stretch, galaxies ripping apart into glowing strands before vanishing completely. This is the most violent end imaginable, the unraveling of existence itself, Nova says quietly. It is creation running in reverse. A long silence follows. Then Nova's voice softens again, returning to a tone of calm reflection. But no matter how the universe ends in collapse, in silence, or in explosion, one truth remains. Everything that exists is part of the same cycle. Creation and destruction are not opposites. They are partners in the dance of eternity. The visuals show the cosmic web again, vast and silent. Its filaments pulse faintly, like a heartbeat, fading in and out. Nova continues, we often think of the end as loss, but perhaps it is transformation. Perhaps the energy of this universe will give birth to something new, something we cannot yet imagine. The camera pans back farther, showing the dying cosmos shrinking into darkness. The music grows quiet, then nearly silent. Nova's tone becomes philosophical, almost like a whisper meant for eternity. Maybe the universe doesn't die at all. Maybe it simply changes form. Maybe it has done this countless times before, expanding and collapsing, living and dying, again and again, each universe unaware of the one before. As she speaks, faint lights flicker across the screen, new universes blooming from the void like sparks. In the end, Nova says, the universe reminds us that endings are never truly ends. They are doorways, the pause between what was and what will be. The final image fades to complete blackness. Then a single point of light appears, tiny, distant, glowing softly. This could be how it began, Nova whispers. A spark in the dark. A new beginning after the end. The camera zooms in slowly toward the light until it fills the screen, glowing brighter and brighter, like the first moment of the Big Bang. Nova's last words echo across the void. The universe will end as it began, not in silence but in creation, for even in death, the cosmos remembers how to begin again. The screen fades to white, the infinite cycle restarting. The brightness fades, the white dissolves slowly into soft black, like dawn turning back into night. After a long pause, Nova's voice returns quiet, warm, and full of something human. And now, she says, we return home. The camera moves gently through the darkness until a faint blue shimmer appears Earth. Small, alone, fragile. After journeying to the edges of time and space, Nova continues. We find ourselves back where it all began, on a small world orbiting an ordinary star in a quiet corner of the Milky Way. The perspective widens. Earth hangs suspended in sunlight, a single spark in the vast black. We have measured the unmeasurable, Nova says, and looked into infinities beyond imagining. But in the end, everything we have discovered about the universe brings us back to this perspective. As she speaks, the scene flows through familiar images. Clouds rolling over oceans, mountain peaks piercing mist, cities glowing under night skies filled with stars. We spend our lives in one small corner of creation, Nova says. And yet, through curiosity, we've seen across billions of light years. Through imagination, we've touched the first moments of time. Through wonder, we've reached the edge of forever. Her tone softens. The universe is not just out there. It is in everything, in every heartbeat, every atom, every breath. The iron in our blood, the calcium in our bones, the oxygen in our lungs, all were forged in the hearts of ancient stars that died long before the sun was born. The camera shifts to a close-up of a human face looking up at the night sky, eyes reflecting starlight. We are made of the universe, Nova says, and the universe in us has found a way to know itself. The visuals move from the human eye to a vast spiral galaxy turning in silence. The same shapes repeat, neurons firing in the brain, lightning in the sky, filaments of the cosmic web. The patterns of the universe are repeated within us, Nova continues. The same forces that shape galaxies shape our thoughts. Gravity pulls worlds together. Love pulls hearts together. The same laws of connection echo everywhere, from atoms to stars. The camera drifts across Earth's landscapes again. Deserts glowing under sunrise, forests swaying in wind, polar ice gleaming under auroras. Nova's voice becomes more intimate, filled with warmth. For all its size and power, the universe is not cold, it is creative. Every star, every planet, every life form is an expression of its desire to exist. She pauses, and the music swells faintly, soft and emotional. We call the universe vast, she says, but its true beauty lies in its unity, in the fact that everything, everywhere, is part of one great unfolding story. Nothing is separate. Nothing is lost. Not a single photon, not a single thought. The screen shifts again to Earth's night side. Cities sparkle like galaxies against the darkness. We once thought we were small, Nova says, but smallness is a matter of perspective. To the universe, we are tiny, but to life, to consciousness, we are the universe made aware. The camera zooms outward again. Earth shrinking. The solar system receding. The Milky Way fading into the darkness. When we look at the stars, we are looking at our own past. When we imagine the future, we are extending the universe's story. Every question we ask is an act of creation, a spark in the cosmic dark. Her tone deepens. The universe may one day fall silent. Its stars may fade, its galaxies drift apart. But in this brief moment, this fraction of eternity, we exist, and that is enough. We are the flicker of awareness in a sea of infinity, a note in an endless symphony of time. As she speaks, the music grows ethereal strings and faint piano echoing softly. The visuals transition to humans gazing at the stars, telescopes turning skyward, rockets launching into the night. We may never see the edge of the universe, Nova says. We may never hear its final echo, but to wonder is to reach beyond our limits. To ask is to expand the universe within. The visuals return one last time to Earth, clouds glowing under sunlight, oceans reflecting the sky. Nova's voice becomes tender, almost like a whisper. The question, how big is the universe, cannot be answered with numbers or light years. It can only be answered with awe. The universe is as big as our ability to imagine, as deep as our willingness to wonder. The camera pulls back slowly past Earth, past the solar system, past the Milky Way, until galaxies fill the screen once more. And maybe, Nova says, that's the greatest truth of all. The universe is not something we stand apart from. It is something we belong to. We are not observers, we are participants, alive for a fleeting moment in the grand story of existence. The galaxies fade into a swirl of faint starlight, and her final words linger in the silence. The universe does not ask for understanding, it only asks that we look up and feel. The music fades. The screen goes dark. For a moment, there is absolute stillness. Then, faintly, a single beam of light appears soft, distant, infinite, stretching across the black. Nova's voice, one last time, whispers, "We are that light." The screen fades to black forever. The hum of the cosmos continues gentle, eternal, and alive.